So, you're looking very exciting, right? Um, so first of all, hello to everyone. It's really great to be here. Wait, we're going to do that. Um, Definitely, we're going to the club tour yourself. But first, let me introduce myself. So, first, my name is Yonatan. I'm doing a lot of stuff in my life. Mainly, I'm running startup in genetics field called Colgene. I'm CTO and co-founder, suffering with all this startup thing, rising investment, development, and by the way, our development here in Kyiv. And besides that, I'm a part of the Google Developer Expert Program. If you're not familiar, this is the global program of 200 experts in various fields, like Android, Firebase, cloud, even for iOS, by the way, we have experts that I have no idea what they're doing in the program, but we have them. And actually, by night, I'm running the largest Android community in the world called Android Academy. It's free courses for everyone. We even bring Google developers, advocates like Florina, to give a workshop for our community. So if you will ever come to Israel, join us. I promise you're going to have a great time. And actually, today I'm going to talk about the Jetpack, right? So you heard the last news, Google I/O. Google announced the Jetpack. It's a set of the libraries and the guidelines that they suggest how actually easy to start development with Android. And specifically today, I'm going to talk about the WorkManager. But before we start with the WorkManager, we need to raise the energy in the room, right? So I have this bar of the clubs. So basically, we start here, and you're clapping normally, right? So, and then as much as I'm raising the bar here, you're really going nuts, crazy, screaming, talking, like that the guys from iOS track will be, so in the camera, I'm going to say this F word, but they will really jealous about what is happening here, right? Are you ready? Yes? Yes? So let's start here, like, hey. Woo! Yeah. Cool. So the story begins actually that someone at some conference asking the friends or actually expert, hey, I have my shiny app, I have a widget, I have no idea why my app is always crashing when I get the update from the widget. And it's a great question to explain actually that the whole story of the background is like it's a hell. Starting from Android O, actually starting from Android M and N, it's become really tough to deal with the background. You need really to think clearly what and how to architecture in order to have the very stable app that can work in the background. And before we start the whole story with the background, there's really important to understand some behind of the memory management of the Android and to see how it's actually affect our all background work. And the story starts the difference between the regular PC, Linux-based, and the device one. So you know that Android is actually based on the Linux kernel, right? But the main difference starts that on the PC we have a swap space, and on Android we don't. So it doesn't mean swap space. Swap space is the ability to take the memory of the process and actually to outload to the disk, right? To our disk storage, and then when we navigate back to our process, is actually to take this memory on the disk and load it back to the RAM, right? On the Android, we don't have it. We have the out-of-memory killer. So this is the guy that actually working together with the activity manager. Activity manager assigned the score for every single process based on its priority. So basically, a priority and the visibility. So if the process like visible to the user and the user interact with that, it's like the most highest priority. By the way, in Android, some have no idea why they do it in this way, but actually it's the opposite. So it's like from minus 15 to the plus 50, and the highest score is actually the highest likability to be killed. So if you have a process with the visible to the screen, guess which score is going to receive? Minus 15. I have no idea why it's that, but actually this is the greatest score you want to be. So. For example, if you're like background application with a service running, not progress sound, regular background service, you're going to receive the priority number 7. Okay, and then the second score is actually, it's also tulipod scores. The second score is actually amount of memory your app is consuming right now. Okay, and then actually when the system feeling the pressure of the memory, out of memory killer start to work. So actually he takes all the processes, say, okay, give me all the processes that have background service running only and consuming more than 10 kilobytes of RAM. And then it just kill them. Okay, free the memory. That's it. The whole story is over, right? So maybe you're familiar, all the callbacks that for you was looking very weird, on-tree memory on this, with different parameters. This is exactly what's happening. So basically the system telling you that, hey, I have a low memory pressure. Before I kill you and stopping you from doing everything, like actually it's killing the process, you have opportunity to reduce the amount of memory that you use. So this is the right place if you want to stay alive, to clean all your memory, to clean all the mess that you created, the all memory leaks, etc., etc. So this is actually 2 minutes about the memory. So why it's important in context of background. In order to have the right priority, in order to out of memory killer not to kill our application, our process, we need to signal him that actually, hey, we're doing the important job. And not long so time ago, we was doing with the service. Service is one of the 4 fundamental components in Android. Activity, broadcast receiver, and the content provider, rest of the free, and the service. And the service was like to signaling to the that we are doing long-running something, and please, please, please don't kill us, right? So this was the main component. And of course, there's additional advantages. It's like additional components, separate the code and responsibility, abstraction, etc., etc., etc. My first application that I wrote. I was heavily relying on the services. And I'm telling in the proudness, but I succeed to drain the user battery from 100% to almost 0 in less than 3 hours. It's like, never did it. Like, no one can beat me. The thing that I did is actually I was like running a background service that was syncing with our backend like every 2 minutes or 1 minute, something like that. Okay, just downloading again and again the same photos for my users. It was great. It was like 7 years ago. But somehow, today, we still have very small unknown applications that's still draining the batteries without any boundaries. Okay, they still doing that without being punished, without like actually users are aware that, hey, this is the, so like I'm the advanced user, so I can go to the battery setting and see who is the one to blame, right? But the most of users don't. Mistake number 1, the users know who is draining the battery. The user's already aware of that, and then actually they're voting by bad reviews. So if your app is actually the one that goes for the battery drain, you're going to receive 1-star review with all these blaming comments after that. And this is something that's very important to understand. What does it mean a drained battery? Actually, it's you, like not you, I hope not you, but the other developers that actually constantly doing something in their process. Okay, so you see this is the battery historian, and the top one, the black one, actually the CPU. So you see that actually the CPU is never resting. Once the CPU is never resting, it's just draining battery. It's using the energy like cycles all the time, and actually draining and draining and draining and draining. And that's it. The battery is over. So it's not that there is no battery for Facebook. There's actually no battery for everyone, and any applications on the phone not working at all. So it's mainly like, everyone is doing for himself, right? They don't care about the other application, don't care about the ecosystem. But we are different, and actually Google say, okay, actually the Android team, that we need to improve this somehow. And the improvement starts in Android Marshmallow when they introduced the DOS mode. That significantly was improved in the Nougat. And the DOS mode, if you don't know, is actually the state of the phone once the phone is turned off. So not the phone, the display is turned off. The DOS mode will kick in within a certain period of time. It's very configurable and different between manufacturers. And actually what it means that no network calls, no GPS, no Wi-Fi scans. If your process will try to do one of these things, it's just going to slip. So you'll put the logs, you will see like network call, and then nothing really happened. And then the next opportunity when you can run this network call is actually going to be the maintenance window. So you see the orange spike. This is actually the maintenance window. You have no idea how long it is. It could be 1 minute, it could be 20 seconds. It's very configurable by manufacturer of the phone. So on Samsung, it's different parameter. On the OnePlus, it's another one. On the Nexus phones, it's like, I saw it from the statistic, it's 1 minute. But it's very different. So basically, you need really to start thinking that how you deal with all these background things. And more than that, on the Aurea, Google said, okay, it's great, but we need to go further because we didn't see significant improvement on the user battery. So they saw that there's a lot of things that happen with services in the broadcast receiver. So they introduced a lot of background restrictions. One of them, the ability to register for the implicit intents for the broadcast receivers. And the second one is actually all related to the service. So starting from the Aurea, you can really call for the start service when the app is in the background. Once you go to call it, you're actually going to receive the illegal state exception. And if you start the service when your app was in the foreground, your service is going to die 1 minute after the user went to the background. Okay? So most of us can say, okay, so I'm going to target API 25 and don't need to deal with it, right? Why not? We have a lot of applications, very well-known applications that's still doing that with the runtime permissions, just by targeting SDK 22, and that's it. We don't need to deal with runtime permission. So Android team also thought about that. And what they did, they actually, starting from this August, you will no longer able to update. You will not able to upload new application that not targeting latest SDK 26. And starting from November, you will not able to update your application on the Play Store if you're not targeting SDK 26, right? And even Android Studio going to show you that it's actually the arrow, and then you need to target the latest SDK if you want to do something. So the window is becoming more and more shorter in order to make this improvement. And basically all of this bring us to hope, to understanding that actually the world is changing, the world of background is changing, and we need to think different. And the first really notable thing is actually the services, as we know them today, are no longer usable. They are deprecated. It's not clearly stated in the documentation, but this is what it is. You can longer use the services as you know today. They're not really serving the main purpose that it was developed, to run the long-running task and give the system signal about that. By the way, who said that? Me. So before going actually to the solution and showing what is the WorkManager, I just want to show you what we have today, like before WorkManager. And so let's look on the on very simple network calls. So how are you going to do the network call today? Probably one of the many different ways. You're going to create the executor, right? And you're going to submit some work. And let's look on the My App. So we have user putting the email, password, investing a lot of time, clicking on the login button, and then go to the other application, or actually receiving the phone. And then the question to you, when my app went to the background, my login call, have it succeeded? Are my user logged in? What's actually the state of the application, right? What will happen if the user will navigate back to my app? What is going to face? Are you going to need to go to regain the time to writing the email and password? I think most of you will think the most logical thing, right, is actually to already be logged in. Already invest my time, I write the email and the password, so every time I need to do that. If you think about the defaults that we have today, when most of you are using retrofit with HTTP, something like that, right? Do you have anyone that's still using the HTTP URL connection? I will shake your head, really. Oh, you suffer so much, really. So OKHTTP defaults is like we have 10 seconds for the establishing connections, and then 10 seconds for the read timeout, and then 10 seconds for the write timeout. So if like in default, it's like something like 3 times to retry if we have a problem with the network. So if you will combine all this together, you actually will figure out that single network call could take you up to 1 minute 90 seconds. 90 seconds is the long-running task, right? And you need to deal with that. And I even like not talking about what if your user in offline, right? So like he tried once and then he completely went to the offline. The user went to the elevator, there's no internet in the elevator, what are you doing? How you take care of that? How you take care of your schedule and the call and executing it later? So you say, okay, so we'll switch to the services, right? But you can't. We already figured out we can't use the start services in as a solution. And then there's different alternatives that are available out there. And one of them is the job scheduler, right? Who familiar here with the job scheduler? Okay, so I will over it a little bit. So job scheduler is just opportunity to you to take task, for example, login, okay, login request to the server, and actually to schedule this job, it's called job, to schedule for the job scheduler. You can specify the constraints, you can specify, like for example, you want the internet, you want the device will be charged, you want the space in the storage, and actually you schedule it, and you have no power or control when it's going to be executed. So today, not today, like a couple months before, if I wasn't developing the app, what I was doing, I was trying to execute the network call. If it's not succeeded, or actually the app is went to the background, I'm going to reschedule it with a job scheduler. And the problem with the job scheduler, that back when it was released on Android Lollipop 21, so basically you can use it only with Android Lollipop 21, but it had so many different issues. Like the bug tracker was like exploding with an enormous number of issues, of bugs that we need to deal. So basically, the recommendation was that you can start to use job scheduler safely with the API 23. So basically, in order to use job scheduler, you need to have a min SDK something like 23. Otherwise, you can't do it. Who is the lucky person who have API min SDK 23? So yeah, the problem with that is very clear. So then you actually, the Google thought about that and say, okay, so we need to provide different solution. So there is a different solution called the job dispatcher. Actually, the API is the same, just the names are different. It's coming from the package of the Firebase. It's called Firebase Job Dispatcher, and you can do exactly the same as a job scheduler. Okay, it's even under the hood going to check which SDK you're running, and then it will use job scheduler if it's above API 23. But the still problem that you have no idea, I have no control over when it's going to execute it. So like you reschedule it to the job scheduler, and then your user navigate back. If your call wasn't executed before, we're still stuck, right? We need to manage it somehow. And even more, one of the biggest problems was job dispatcher, that job dispatcher is relying on the Google Play services, right? So it's one of his dependencies. And Google Play services is actually missing on the tens of millions of the devices. So like it's an enormous number of customers out there. And if you're there, like if your users are using your app, by the way, it's a lot of users in the state. On Amazon, for example, Amazon phones don't have Play services. Amazon Fire TV, that is number one popular in streaming in the US, don't have Play services. And I'm not talking about the hundreds, dozens of Chinese devices that don't have Play services either. So it's like tens of millions of the customers out there that will have ability to use your app smoothly. So what we're doing for them, so probably you're going to have to manage some kind of alarm manager with alarm that firing every time, and then checking if there is internet, and then try to execute it. And then actually you will find yourself fighting with a wake lock pain because your CPU is actually going down at the same time when you're executing the network call. And like, it's mess. And I'm not talking about the rescheduling and constraints, and I'm not talking about like, hey, someone restarted my phone, so hey, I need to put the boot completed receiver, I need to take care of all this process. It's like, it's insane, right? So I hope you feel the pain by now. for me, it was like really, I thought that I reinventing the whole framework again and again with every single network call. And lucky us, we have a work manager. So Google was thinking about, and WorkManager is actually using all the things that I just described right now. So now we actually understand why we need WorkManager and how it's work beneath. It's doing exactly the thing that we just described. It's using the job dispatcher, job scheduler, alarm manager, and executor underneath in order to execute your calls. You just submit the work, and everything is done for you. And we're going to explore that. And why I'm talking about that is I truly believe that you're a much better developer if you understand how the components that you use are working under the hood. So this is your opportunity to learn, and I will share with you all the things that I learned in a tough way, and I'm trying to bring you back to the community. So the architecture of a work manager is pretty simple. So we have different components, and I will work with you over these different components, but it's really true. Great opportunity to understand and look under the hood. So when you go home after my lecture, I encourage you, look in the source code. It's available out there, and just look how beautiful it's built. Of course, there's a lot of issues, and we'll talk about them later, but do it, please. You will become a much more better developer. So our journey starts with the worker, and the worker is actually it's the class that you need to extend. Actually, this is the class that's doing your work. So it's already running on, it's have only one method called doWork, and it's already running on the separate thread. And it's already taking care of wake logs and all this pain of rescheduling and other stuff. So basically, you just have this only one method that you need to override. You do your work, and you need to return the result like success, failure, or reschedule. That's it. It's simple like that. What kind of work you can do? Like, for example, here I was like taking the location from another worker, for example, and sending to my server. And then also I can use like inputs data from different sources. And the next component is actually we have a worker, right? So we have a work to do, and then we have a work request. Work request is actually it's wrapping for the work as it meant it. Is work request, and it's receiving the constraints like internet, for example. We need to be connected to the internet. It can receive the input data. Like in my case, it's receiving the location. The structure of the data, the input data, is very simple. It's just a class that's holding the map, the hash map. So it's limited to up to 2 megabytes. So it's like only strings and primitive types. You can't really put their like entire network or entire app management, something like that. Okay, it's intended to be very, very small. And then actually you create one-time request, work request. You put your constraints, you put your input data, you call for the build, and you have the work itself. The next, you need to pass your work to the work manager in order to schedule it. So it's looked like that, very simple, one line of code. Get the instance of the work manager and enqueue the work. And that's it. Basically, at the work is over. Your call is going to be executed. And under the hood, actually, what happened, there is a class called processor that actually is going to figure out which scheduler is the most sweet for your need and fit what is actually the state of the device. So it's like, firstly, it's going to try to execute it with a grid executor. Like the regular executor is just called grid executor, great name. And really try to do the best to execute it right now. If it's not succeed, it's going to reschedule it, or either with a job dispatcher, or with a job scheduler, or with the alarm manager, the regular alarm manager, and we'll really try the best to execute it as soon as possible. And it will take into account all the DOS mod and the constraints of the background, the priority, and if the process was killed, they need to reschedule it again, etc., etc. It's saving all the states and all in the input data in database. By the way, they're using room under the line, under the hood. And once the work is done, it's going to publish results to whenever I want to, or observe the results, or to see that the work is done. And by the way, it's using the live data to publish it, so you can subscribe to updates from the live data. I'm talking here about the live data, the room. Who is familiar with that? Oh, great, cool. So I can continue to talk about that. So in the code, it's very, very, very simple. You take the ID of the work, and you can, using the work manager, you can observe on the results of your work on the live data, so basically the live data with the status inside. And once the status is updated, of course, you need to check if there's a status, if the work is kicked in. You check if it is finished, and then you can safely take the output of your work, if there's any, and do whatever, like updating UI with it. Of course, you can run the periodic job, so there's a periodic work request. It's have the same API. The single difference is that you can give the time period. By the way, the time period is the minimum is the 50 minutes. Why is that? Because the job schedule, the minimum of the time period is the 50 minutes as well. So you can't run work more often than the 50 minutes. Of course, you can chain the work together, so you can run the work one after another, or you can run the work in parallel. So like, scan the book with 10 different workers. So everyone's scanning different page, then you merge the results and send it to the server, for example. Okay. One note, you can chain periodic job with a one-time job. But you still can overcome it, by the way, by scheduling the one-time job before your periodic job is finished. So inside the do work, you just schedule one-time job, one-time work. I was confusing job works. Like for me, it sounds the same. Cool. The canceling is very simple. So basically, you can cancel by ID. So when you create the new instance of the work request, it's create the work. You can take the ID of that, okay? And it's unique ID per instance of the work request. And then with that, you can cancel it using the WorkManager by calling cancel work by ID. There's another way to cancel the things is actually you can assign the tag. You can add tag when you're building the work. And actually using this tag, you can cancel it. It's much more robust, I think. Like from my position, like maintaining UUIDs is very hard. So using the unique tags is much more simple than managing. Like you have much more power than just randomly assigned ID that have no power over it. So great, but what about the real life scenarios, right? So it's in the theory and the API is looking really, really great, but how I can use it tomorrow, right? Let's talk about tomorrow little after that. It's still an alpha, but how actually you can use it. And let's take the regular scenarios. We have like Star Wars, Tinder, something like that, and you open your app and you want to download the profiles, right? So you will make your calls to the server. The server will return some response in like profiles, names, images, and other stuff that you need to parse, right? Very regular. Every app is doing that, right? So the most simple, the most dumb version is like we will create our activity, right? And the activity we will call for the constraints. We need the internet, right? We need to download it, and then we'll create the one-time work request. I call it profile fetch worker. We pass the class, the type of the class that of our worker. We set the constraints, call the build, and actually we take the instance of the WorkManager and we call to the enqueue. At the same time, our do work going to kick in, so worker start to work, do work going to start. We will call to the download all the profiles from the network. We will parse it from the list of the profiles to the data class, right? And actually, we will set it as an output to whatever is observing of our job and return the success. Of course, there's a lot of different things that we need to take care of it, like if it's the network call is down, so maybe we need to reschedule it, or if there's no authorization from the server, again, you need to think how you overcome. But in the simple version, this is how it's look. And then they need to look on the updates, right? So we set output data, all the profiles in the data format, and how we observe. So we take the UUID of our work, and we subscribe, actually observing on this using the WorkManager for any changes in our live data of the work status. And once the work is finished, we can easily take the data, the output data, and let's say call to update our UI, right? So this is the simple solution. But in reality, some of you were going to use some kind of MVVM or MVVP pattern or clean architecture, thanks to the Fernando. And you actually need to much more robust solution, because what happened then, activity is down, then there are actually calls and other stuff. So if you like, you will have the view, could be activity, could be fragment, and the view going to have the view model that start the job, the work, and they have this live data observing thing. And then our profile fetch worker is going to kick in. We're going to make the network request. And once we'll have the data back, we're going to call on change. Actually, when the work is finished, we're going to call on change. Actually, not we. The do work will do it for us. The worker will going to do that for us, and our UI is going to be updated as well. Right? It's looking great, but what happened when the user is going to the background? Even more, what happened when they don't have the internet? How we take care of that, right? So like the simple scenario is actually they make a call, right? We downloaded all this fancy data. We already spent the kilobytes. And then who we update? There's no UI, activity or fragment already that, right? If their life cycle is over, they're on destroyed state. So like we just downloaded it for free, right? Like no work. And our users are upset because they come back to their app and the state is blank, right? They need to download it again and again and again. So we need to think about much more robust solution. And here, all the Jetpack solution actually under architecture components and come into the house in order to help us to solve this thing. And maybe this diagram is looking like very complex, but I promise it's very easy, and I will convince you. In a way, how we can build it using the under architecture components, the full set, because all these libraries are intended to build to play nicely together. And it's very simple. So we start with a view, right? And using under architecture components, we can expose our life cycle to out of the world. So the fragment have life cycle, right? So the activity have a life cycle. So we can easily observe using this life cycle without being aware that actually this activity is down, because it's taking care of all these things that when the activity is live, is not live, when you start to stop to observe and not stop, and preventing all these leaks. And actually, so when we start our activity, our view is going to initiate the view model, right, to create the view model. The view model going to make immediately the call that, hey, this is the main activity for profiles. I need to show the profiles. So our view model actually calling to the profile repository, right? So everyone is liking the clean architecture. Going to the profile repositories, and the profile repositories say, okay, I need a data to show something to the user. And the most simple way before going to the network is actually to check if I have something on local on the device, right? To benefit from the local storage. So we go to the room database. That actually the room database, if you're not familiar, is a wrapper on top of the SQLite, and make much more life easier to work with the databases. So we're going to ask for the profiles, and we immediately will get back the instance of the live data of the profile, because one of the great things that Roomies provide us is actually give us the object, the live data with the list profiles, and once there's any change that happened in the database with the list of the profiles, we immediately got updated. At the same time, our repository going to call for the network requests, so like profile network data source, like the one taking care of all these network calls, and it actually will also have the mutable live data of the list of the profiles. And it's going to schedule our work using WorkManager, and our worker going to the internet, going to download it and download all profiles. So once the download profiles will finish, we're going to receive the success. We will set the output data. Our profile, our network data source will got updated with this because he's observing on the status of the work, right, automatically. And the only thing that we'll have to do for our network source is actually to take this data from the worker and to pass it, and actually to post it on the mutable live data that our repository is observing, right? So our repository will be updated directly, and the only thing that left to do to the repository is actually to insert into the database. That's it. What happened next? Because our UI is observing for any changes in the database, we immediately got the update through the view model to our view that the data is changed. The list of profiles is actually the new list of the profiles, and show it to the user. See how simple it's become? So basically all the updates, all this chain of the updates become much, much, much more simple to manage. Of course, it's very simple life case scenario. The other thing that I got asked a lot is actually how I manage all these location things, right? So one of the restrictions is actually how I get the last location of the user while our app in the background. So before the WorkManager, I was building the app like that. So I have like activity that's scheduling the service, and then from the servers I will going to create like kind of handler, handler thread with a looper because I need for the asynchronous call from the GPS providers. I'm going to create the location handler, the one actually going to run every 50 minutes and get the location updates. And then I will create the actual location tracker, the one that actually doing the work of obtaining the GPS location and deciding if it's a good location, bad location, and what is the accuracy. And once he decides it's a good location, I'm going to send it to the network handler that taking care of all the things about the uploading it to my server, like, for example, Firebase. But it's not, the whole work is not over, because then I will need to take care of actually keeping my service alive, right? So if my service was killed for any reason, like I need to have the alarm manager firing every 50 minutes, checking if the service is alive. If it's not alive, start it again, for example. And what if the device is rebooted? So I need something like boot completed receiver in order to restart the service again, right? In order to get the location from the user every time. With the WorkManager, it's become much more simpler to achieve that. So we'll have the WorkManager that's scheduling the work request, the location work request, this is periodic work that's going to run every 50 minutes. And inside this location work request, we're actually going to have the location tracker with all the things. So this is actually how I started the thing, right? So I already have a thread, so I don't need to take care of all this stuff, that separate thread, separate looper, and other stuff. So I can easily using the location tracker, the one that will take the GPS, taking care of deciding the best location, sending to the another work called upload work, the one that actually will going to upload it to my server, right? But unfortunately, the problem here is that the do work is this is actually the synchronous call, it's synchronous execution. So there's no way actually to make it asynchronous. It don't provide any callbacks opportunity to start the work and actually to give the results back somehow from the other work that was started. So we need to turn now to asynchronous job, because all our calls to the location are asynchronous. So we can request the location update, we pass the looper, we pass the listener for the updates that listen for on location changed, and once we receive this new location, we're going to do something, right? So actually we have a synchronous execution in our work. We have asynchronous execution of location request, how we can do that. And actually, we need to tweak a little bit the do work. And we can stop the execution method using like block methods from the language. And here in my example, I use the countdown lodge. Who here are familiar with the countdown lodge? OK, so for those of you who don't know, it's a very simple mechanism. So I can define, like, in my example, let's just skip to that. So my example, I can define like countdown launch 1 and call for wait. And then actually, until another thread will not call on my latch countdown, it will not free this thread from executing the rest of the code, right? So actually, my current thread, after I will call a wait, will sit and wait till someone actually will call down on my latch. Okay, so this is the solution. So basically, I stopped this method from the execution because I need to finish my call of getting the last updated location. And under hood, it was looking the same way. So I need a separate thread. So I created the handle thread. I took the looper. I created a location handler, a location tracker, call for the start. Once I get, and of course, I created the countdown latch with 1. And once I get location, I was like the continued execution. Of course, don't forget to clean up. We need to clean all these handlers and threads and loopers to stop them, because otherwise it's memory leak. And I was returning a success. The scheduling of this kind of work is very simple. You just call for like periodic work request. You specify the constraints. You specify the period of time. So here it's like minimum 50 minutes, right? And we just call for the enqueue. That's it. That's basically the all next. So what's next? This is like opportunity is really great, so we can get the location. But still, I think we can make much better. Because usually, why you need this location update every 50 minutes? Because you want to do something basic on the user location, right? To provide him like with the context, maybe with advertisement, where maybe with like if someone arrive at home and you want to send him push notification, hey, you're at home, do you want to turn the lights on if you have smart house, for example? Or if you, like for example, in our case, I was working at the Get, we was like having geofence location for your home address. And once you're waking up at the home and you get out of your home at the morning, we was offering to schedule you a taxi call. Okay, so basically to provide much more user experience, greater user experience based on the location. So this is the case. So we don't need location every 50 minutes to figure out. So we can use the geofence. And the geofence, why I'm talking about, is a great example of when we need something to do something based on the system. Okay, and the way we can do based on the system state, and the geofence, by the way, is the system state because it's managed from through the Play services, is by scheduling the pending intent. Okay, so if you look, by the way, in the documentation today for the pending intent, you will see that it's still suggesting to schedule running and using the services for that. So I decided to address that, like to help you to figure out how better to use all these background restrictions. And actually, the first point that you need to understand is that you need to use explicit broadcast receiver in order to receive. So we will going to create the geofence request. So every time when our user getting inside or outside of geofence inside of the location, the one that we defined. Geofence, by the way, I didn't mention it, sorry. So geofence is basically I can define the location, the point, and the radius. And if my user are entering or exit this radius, I can be popped or actually be notified about that. And I'm notified by the system. And the way I notify is by passing the pending intent. Pending intent is just like regular intent with permissions like your app, because this intent is fired by the system. And if you don't know, the system don't have the same permission as your app. So we need to give this permission to someone that's going to fire this pending intent, and this is the way to give this permission. So it's basically the same as the intent, just with the permission of your app because it's fired by someone else. So we're going to schedule the pending intent, not to schedule, we're going to create the pending intent to give it to the geofence client in order to be fired when the user are leaving the geofence or actually entering the geofence. So this is the case scenario. And the way we can do it is, so in the documentation says the services, but we already learned that we can't use the really services in the background, right? We're going to have the illegal state exception. And also we can't use implicit broadcast receivers. Why? Because when you will try to do something like that, you will try to specify the action, you're going to receive the illegal state exception as well. It's going to tell you that the background execution not allowed and throw you all details of the intent that it's trying to use. So basically, in the way you need to solve it, you need to specify, you need to create a receiver, the explicit receiver that you're going to use by implicit call, by explicit call, just to specify the class. And this is actually the pending intent that should be fired. This is the only way that you can do. The only explicit intents going to be served by the system when the app is in background. It's also one of the background restrictions in Android area. So we create the receiver. You create the once the user are reaching the geofence, actually going out of the geofence, you need to take care of the location. So you take the location, you create a you converted it from the location to the data format. You specify it as the input to our work request. You create this work request, and actually you schedule it, and that's it. So all these fancy things with the geofence, with the starting service and taking care of different execution is over. Just like 3 lines of code, and that's it. So it's on the paper, and in my labs or finding the solutions, it was looking great. But you don't need to forget that this is still alpha version. Already hired a couple of folks already using it in the production, so I'm like, I admire you. But it's very, very painful. There's a lot of issues still out there. The Android team is working on resolving them. A couple days before, 0.2 version already was released, Alpha 0.2, with a lot of changes and fixes, but still, it's alpha version. And like, don't put it in the production probably. But it's already everyone outside of the world understand that this WorkManager have much more robust API. Because it is working together with the system, it can provide much more stable API and leverage all the system states. So even the Android job from the Evernote announced that their library will reach end of line as soon as WorkManager will become much more stable. So, you don't have any choice, and till the WorkManager will become the badass of all background jobs. And actually, to become the badass, we need your help, right? I really encourage you to try these things, to see how it can work for you, for your solutions. If it doesn't work, you have a bug issue tracker. It's not just a place where you put the things and nothing is really happening. It's really team and me as part of this program. We're looking on these issues, we're looking on these solutions and requests, and we really try to do the best. So only together with you, the community, the developers, we can create this WorkManager with the great APIs that can serve our users, you, and make the developer much more easy. So thank you, guys. My presentation will be available on the Twitter. I will just upload this after that, so follow me if you want. And that's it, I think. Yeah, it's over. Done. Thank you. Questions? Yes. Who will be the first? With the brave one? No? Yes, yes, I know there's a question. I know, I knew that.
Hi, I'm Tim from Pletica, Vinnytsia. I wonder, can you provide an example when you want to use a WorkManager and starting a job with some request constraints, and the constraints is not satisfied? What happens?
Your work will not be kicked in. It will just not start.
So I have to reschedule?
No, you don't need. You specify the constraints. The work will start when all constraints are met. That's it. And if there's no, if you had the internet and then it's gone, it's going to be rescheduled automatically. You nothing need to do that.
Hello, thank you for your speech. How we can observe result of WorkManager without live data?
Without?
Without live data.
So basically, the live data itself is bounded within the library. So you can't really explicitly need to put the live data dependencies. It's already there. So you can't really take the. I know what you're asking. You want to RX Java, right?
Yes, of course.
So you can't really do that. Maybe, I'm not promising anything. Maybe it will be added later. But right now, the only way to observe for the data changes, for the status changes, is using the live data.
Okay. Thank you.
In general, by the way, I think that, it's my personal opinion, not related to the Google, I think the RX Java is just over-engineered concept, and the live data is much simpler one. It's just like, I saw a lot of teams struggling with having the same agreed on everyone the way working with RX Java. And because the live data, there's only one way to do that, it just makes it much, much simpler. So maybe we can think about migrating to that. Or I think the Google I/O theme. Yes, questions, the brave one. By the way, if you have a problem with the English, ask in Russian, I will translate it. Yeah.
Please, can you tell what are still the cases when it's better to use services?
When it's better to use services.
When will you not get this illegal state exception?
So there's a couple ways that still services can be useful. First of all, if you start the foreground, so foreground services is the one that you attach the notification to that, and user explicitly see that there's a background service that is running. So it's no longer background, it's foreground, because there is a notification in the user phone. You can still use that, but the users are going to know about that, right? So think about I already saw the solution that someone put the foreground services. So I have every 10 minutes I have a foregrounds popping on my screen, a notification that is some application doing something. Think how long it took me to uninstall this application. It's just to figure out which one is showing this notification. Another thing is running the bound services. So if you have bound services that are the activities, or can be bounded to the service for your like AADL service. Okay, I'm talking about that. So it's a very legit way of still using the services. But it's more like, who can write here services with the AADL interface? So, yeah. Any others? So I will be available there, I guess, after the talk, right? So after like, where's the coffee? Huh? In lobby, yeah. So you can come freely. I'm not biting. I'm a really nice person. You can ask me a question, and I will freely to help you. Thank you, guys.